We're all pretty used to how electricity works in our homes. You flip a switch, the light comes on. Simple. But what about on a giant steel ship floating in the middle of the ocean? Well, it turns out the electrical system on the high seas is a completely different animal, built for a world where failure is just not an option. So let me just ask you this. When you picture all the thousands of wires running through a massive ship, powering everything from the engines to the navigation systems, which one do you think is the absolute most important? Is it the big thick one from the generator? What do you think? Well, believe it or not, the answer is kind of weird. The most critical wire on that entire ship might just be the one that, if everything is working perfectly, does absolutely nothing. It just sits there, carrying no current at all. Confused? Good. Let's get into it. See, we're talking about the neutral wire. Now, its job sounds simple on paper, but the way it's used at sea, that's a masterpiece of engineering. And it's all designed around one single priority: keeping the ship running no matter what. Okay, so every electrical circuit needs to be a complete loop, right? You can think of it like a racetrack. The power flows out from the source, goes through whatever it's powering, like a light bulb, and then the neutral wire is the path that brings that current right back home. If you cut that neutral wire, the circuit's broken. Nothing works. But here's where it gets really cool. On a ship, the power is typically generated in 3 phases, and when all the electrical loads are perfectly balanced between those phases, something amazing happens. The currents actually cancel each other out right at the neutral point. The result? 0 amps flowing through that neutral wire. It's literally doing its job by doing nothing. That's the dream scenario. And this is where a house on land and a ship at sea go in 2 totally different directions. It all comes down to how they answer one critical question. Think about it. In your house, if a live wire accidentally touches the metal case of your washing machine, a circuit breaker trips instantly. The power cuts off. It's designed for immediate, foolproof safety. But imagine that same logic on a ship. A single faulty wire plunges the entire vessel into total darkness in the middle of a storm. Not good. And this slide lays it out perfectly. On land, your system is grounded. The neutral wire is physically connected to the earth. So when a fault happens, the current has a direct path to the ground, creating a huge surge that trips the breaker. The goal is instantaneous safety. But at sea, the system is insulated. The neutral is not connected to the ship's hull, so a single fault has nowhere to go. It doesn't trip a breaker, it just triggers an alarm. The goal here isn't just safety, it's reliability. This whole design is called the Insulated Neutral System. And you can think of it as the electrical lifeline that lets a ship operate safely in some of the harshest environments you can imagine. I mean, the reason for all this is pretty straightforward when you think about it. You can't just pull over to the shoulder in the middle of the Atlantic. Losing your engines, or worse, your steering during heavy seas is an absolute nightmare scenario. So the entire system is built to take a hit, to tolerate one fault without shutting down. It buys the crew precious, precious time. So how does the system actually pull it off? How does it give you that critical warning without just throwing in the towel? Well, it's a calculated risk, a brilliant balancing act between keeping the lights on and preventing a total disaster. Okay, here's the play-by-play. When that first live wire makes contact with the steel hull, nothing big happens. No sparks, no shutdown. Because the neutral isn't connected to the hull, there's no complete circuit. But a special device senses this leak and sounds a loud alarm. The engines keep turning, the lights stay on, but now the crew is officially on the clock. They have to find and fix that fault. Why? Because if a second wire from a different phase also touches the hull somewhere, you've just created a massive direct short circuit through the body of the ship. And that means catastrophic failure and a sudden blackout. And this brings up a golden rule for every marine engineer out there. Even in this incredibly clever system, you have to respect the neutral wire. If the single-phase loads on the ship, things like lights and outlets, aren't perfectly balanced, that neutral will absolutely carry current. You never, ever treat it like it's a dead wire. So that alarm is blaring. The clock is ticking. How in the world do engineers hunt down one invisible electrical leak on a moving steel giant that could be hundreds of feet long? They've got a specialized toolkit for the job. They'll grab a multimeter to look for strange voltages, a clamp meter to see if current is flowing where it shouldn't be, and an instrument called a megger, which is specifically for testing how good the wire insulation is. But the most important tool of all is the one that started this whole process. This guy right here is the guardian of the entire system, the Insulation Monitoring Device, or IMD. It is constantly watching, 24/7, sensing even the tiniest bit of current leaking from a live wire to the ship's hull. Without this device, that first fault would be totally silent, and the second, catastrophic fault would come as a terrifying surprise. So, with these tools, it really becomes a systematic detective story. If the IMD alarm goes off, they know they're hunting for an earth fault. If their multimeter shows that voltages are all out of whack, they'll start looking for a broken neutral connection. Every symptom points them in the right direction. It's all about finding the problem based on the clues the system gives you. And in the end, everything we've talked about comes back to this one powerful idea. Yeah, the insulated neutral system is more complicated, and it definitely requires more attention than a standard system, but it's designed that way for a very simple reason. On a ship, reliability isn't a feature. It's not a luxury. It is the absolute foundation of survival. It really makes you think, doesn't it? This is just one example of an ingenious, almost invisible system that's designed to keep people safe. What other hidden engineering marvels are quietly protecting us every single day, in our cars, our buildings, or even the phones in our pockets? Definitely something to chew on. Thanks for watching.